G-Shock on the beat though.
Listen up, class. We're going to talk about calculus. We're going to make some BC seem like it's extremely easy. First off, you're a fool if you don't know basic derivative rules, so let's get to work, because we got a lot to cover. Let's go.
Derivative of x to the n is really easy. All you gotta do is n times x to the n minus 1. Derivative of uv is duv plus v du. And you can always be sure that it will always hold true. Implicit differentiation is nothing more than a special case of the well-known chain rule for derivatives. The majority of differentiation problems in first year calculus involve functions of y written explicitly as functions of x.
See, that's not hard. Your brain clears a marred. Now that you are ready, let us talk about MT. MT tells us when certain values exist. This is very useful, so use it, I insist. There lies a point, see, between x equals a and b. Use it in your class, you'll be shouting with glee. IVT always has a point between a and b. As long as it's continuous, continuity is key. Then there is an x where f of x equals c, fd, fc, continuity will be seen. Now let's talk about EVT, which is as simple as 1, 2, 3. If f of x is continuous on x equals a to b, then f of x has a min and a max on a to b. Rolle's theorem is just as swag as a Rolls Royce. If f of x is differentiable and continuous from a to b, and f of a is equal to f of b, then there is a point c such that it's equal to 0.
Curve sketching, that's almost as easy as drawing. All you gotta do is memorize some facts. Curves are increasing when 0 is less than f prime, just like I beat you when you run out of time. Curves are decreasing when 0 is greater than f of prime. See, it's just as easy as tying a tie.
Trigonometry, that is not a dilemma. Conquering integrals without any fear, yo. Power rule happens to be really cool. Integral of x to the n, easy. All you gotta do is x to the n plus 1 over n plus 1. Riemann sums are approximate areas under the curve. Too high, too low, that's what they all deserve. U sub is just an inverse of a chain rule. Sub in u for a part of the function in the pool. If you notice the integral, that will also be helpful too.
Come back, we are not done yet. Sit back, relax, and try hard not to run. Finding area and volume ain't that hard. There's no need to be really scarred. Just take the integral of the top minus the 1 on the bottom. Then you become all set to be considered awesome. Volume of a rotated function isn't bad either. You just gotta determine if it's a disk or a washer. If it is a disk, then you can do pi integral of r squared. If it is a washer, then you pi integral of big R squared minus little r squared. Calculating the arc length of a function is easier than navigating a T-junction. You just do the integral of square root 1 plus dy over dx squared, which gives you the length of the line segment. Taylor series is a series expanded around the point. The polynomial we get can be used to find the approximation of a function, dude. If the polynomial is around 0, then we call it the Maclaurin, yo. Convergence and divergence tests are the most unpopular, but they are extremely useful, like a speedometer, p-series, n-term, geometric, and ratio will all help you get the answer, yo. During convergence, the partial sum approaches a limit. In divergence, there is no limit. The sum approaches